Hey, welcome back everybody. Alright guys, we gotta have a quick talk, and this is in relation to a couple of questions I've gotten in the comments over the past week. And if any of you guys have seen some of the aviation news lately, you might have seen an article or several, because I've found several of these, about the Collings Foundation parking the Wings of Freedom Tour aircraft. And a lot of the questions I got was, what does that mean for us here at the hangar with the F-4 and the other jets here? Well, I reached out, and one thing I want to make clear is I am not an official spokesperson of the Collings Foundation. I'm just one of the volunteers on the F-4. I'm the goofball with the camera. So I can't speak on anything officially for the foundation, but I did reach out, and they do realize that there's quite a few followers, especially of the Phantom here. And so I was able to get something for you guys. So right now, the foundation is headquartered up in Stowe, Massachusetts. I mean, that's on the back of it. Well, not this one, but it's on the back of our t-shirts. And the Wings of Freedom Tour aircraft was comprised almost entirely of World War II warbirds. So a lot of those aircraft are going to get parked, and part of this is they're building a huge facility. They're doing an expansion of the facility up in Massachusetts, so they can do long-term preservation and display of these very aircraft that they're parking. Now, there's always long-term plans for the parking and preservation of aircraft, and eventually this one and the other jets here are going to be in that position. However, the good news I can share is there are no plans currently to park any of the aircraft here that we keep down here in Houston. That's the F-4, the A-4, the T-33, the Huey, the F-100, and the ME-262. And in the 262's case, I can only speculate personally, since that is not a World War II original. That may be an exception to most of the World War II fleet for the Collings Foundation getting parked. Imagine the 262 being a 2002 edition aircraft. That one's going to keep flying for quite some time. But there's always long-term plans, like I said, as far as parking the aircrafts, and I know there's going to come a day where we're not going to be able to maintain this in a flyable condition, due to either lack of availability of parts or something along those lines. And that's the same for the other aircraft that we keep here too. But I did want to address that with you guys and share the good news is that there are no plans to park any of these aircraft. We are still continuing on to make sure that these aircraft are flyable and they keep flying and preserve that history and their legacy, especially on the Phantom, arguably one of the most iconic fighters of the Cold War. So wanted to bring up that and share that with you guys. All right, let's get back to work. All right guys, we're back yet again for another fun-filled weekend, and we're going to continue troubleshooting the right-hand TR circuit paths. But first things first, what we want to do is check to make sure that the signal paths are good from where they need to go and where they end up going as far as their where the voltage is supposed to go. The sequence is whenever you plug in the ground power plug and turn that on, the ground power TR powers up, and that allows you to apply external power using the switch panel in the front cockpit. That powers up all the AC buses, which turns on both left and right main transformer rectifiers. They power up, and that right is supposed to power the bus. We think we may have a problem with that, so we're not going to apply power today, but what we are going to do is troubleshoot those pathways to make sure everything's good, so we don't, one, keep blowing fuses and possibly burn out another ground power TR, but we also want to make sure everything's good before we move forward with that right main TR, because we want to make sure that there's nothing wrong with the electrical system before we power that up, because if there is and we burn up that one, we're in no better position than when we started a couple months ago. All right, let's get started.
There it is, hitting. Let's see where it's hitting. Okay, there's a big Canon plug that connects to this. That's not going to let it swing down.
I don't know. All right.
Yeah. So,
Okay.
and it looks like it'd be tough to get to.
Yeah. Okay. Gotta get back there and look at that diode. Well, all right. All right. Now to get panel 3 out, this Canon plug back here was getting blocked by the gyro box that was right here, so we removed that. So now we can get to this and everything else that we need. We got the bolts back up in the top here, so now we just got to slide this out. Now again, what we're trying to get to is the back of that breaker right there, the warning light controller, because that has that diode mounted on the back of it, so that this will take over for that external power contact transformer rectifier underneath us, and keeps power on the external power contactor in the AC power box, which is down there. But we got to pull this out far enough because there's a lid on the back of this. So I'll set you guys down and we'll get this out. How much more is on here? There we go. Now she's free. The whole thing is covered. Alright. Now we gotta disconnect those Canon plugs down there too? Alright. Oh, now we gotta get those. Hey, had to get this box out. Now we can get these loose. Come on, get out of there. There we go, we got one. Now I can get these on this one. And let's see, that's tight, that's loose. Huzzah! And ta-da! Circuit breaker panel number 3. And pretty darn well covered. So now we got to get to the back of this thing. Yay! Hey, it's the original one. 650749. Look at that.
That's cool.
Awesome. Alrighty. There we go. And which end do we got? Let's see. Warning light controller, that side. So. Ah, here we go. Come on. Open. Please. There we go. Alright. Warning light controller. Down here. That one. There should be a diode somewhere underneath it. Or near it. That's what it says inside the book. Alright. I think we found it right there. What's our book say? 4CR343.
That's it.
Yep, so T.O. over there says, there's our diode right there. So, alright, let me show you what we got. right here, so here's our ground power plug, and the three main AC power lines, A, B, and C, come in. The A phase is tapped off right inside the plug on the jet. It comes down here, it goes to that ground power transformer rectifier that you've seen us replace before. And there's that fuse that blows, which, right there. And then, what leaves here is 28 volts right here on pin 3. Comes up. And comes up to, back to the power plug on pin F. It gets looped inside. It gets looped inside the plug here. So it leaves the jet on pin F, that 28 volts comes back on pin E. There's just a simple loop inside there, and since those are the short pins, if that plug isn't fully seated, then that wouldn't make contact, and then you wouldn't be able to apply ground power. So, and then that comes back up, pin E comes over here to our generator switch control panel, and you put them in external, and that comes over here to the AC power control box. We know that pathway does work. Here's the problem. So, on circuit breaker panel number 3, we got this source right here from the right-hand transformer rectifier that we just replaced, and the warning light controller 49CB303, which is that guy over there. So that has to be closed and good, so we'll meter that here very shortly. But it splits off and goes to the cockpit warning light controller up in the forward cockpit here on pin D. Right here, it also splits off on the protected side of the breaker, passes through that diode that I just pointed out, and then leaves here on pin K and ends up back on the ground power control wire. So what that means is, once we switch on external power on the jet and that ground power transformer's power closes the ground power contactor, the right hand transformer rectifier gets power and starts producing 28 volts. That 28 volts comes through here, passes through this diode to take over for the ground power TR. Now, if that diode's there to keep this from backfeeding the right-hand electrical bus, and also keeps the right-hand power to pass through. Now, if that's open, then the right-hand TR will never take over and power that bus, and will overload this and blow its fuse, as it has been doing. So, there's that breaker. We're going to meter that for continuity. I'm going to find a way to disconnect this and see what we get out of this. Alright, so now we want to verify we got a good circuit breaker, which warning light controller is this guy right there. So right now I have it popped open, and we should see OL on the meter. And we do. Now if I close it, there we go, closed. Now if I close it, we should see a very low number and a beep. So that breaker's good. So that 28 volts comes in on this side and leaves this side because you got the two wires here, and it makes its way over to this diode. So now I got to make sure that this signal path works. Alright, I got access to the center pin, so we should get continuity at least from here to here. And we do. Alright, now to check that this thing is actually doing its job. Where's that pin? Right there. Alright, so now we gotta enable the diode checker function on this. That's capacitor. There we go. So, if we got this right, if the diode's good, it should read this go in one direction and continuity go in the other direction. But if it's open both directions, then we got a bad diode. Let's see, right there to there, open. Diode's good. Alright, so now I want to make sure that it's actually coming from here and going here to the connector plug on this. Oh. Now we want to make sure it's actually coming from here all the way over to here to the connector plug, this one. So now I gotta go find a paper clip to get into the right connection there. Alright, so I located pin K there. So I got my meter lead way over here. Now I'm gonna forward bias this diode and make sure we got something working. And it does. Alright, so the diode's working, at least as far as we can tell. I'm gonna leave that in there and try to reverse bias the diode, and we get nothing. For those unfamiliar, diode simply acts as like a electrical check valve, so it only flows power one direction but not the other. And that's what we want in this case, because we don't want the ground power TR to backfeed this panel and try to power up all the right-hand transformer, or the right-hand TR, the right-hand DC bus's loads, because that's a very small transformer. So that works. Go back to this. And that works. Alright, now let's also make sure we don't have a ground. We definitely don't want that. So let's go back to continuity. Okay. So the panel itself is not grounded. Okay, good here so far. Alright, now what led us down this pathway was back during the air show when we dropped the, when we lowered the wingtips down, what we used was the battery to power the essential bus, applied ground power. That would allow the ground power contactor to close and apply power to the left-hand transformer rectifier, which is good. And that would power the right-hand bus through the bus tie. And during that process, I think it was when we brought the jet back, that's when the power dropped again. So that's what led us here to make sure that this pathway works, is to make sure that the main TRs take over for the ground power TR. That's the one that keeps popping fuses. Because if for some reason those TRs are not powering and taking over, then that ground power TR is going to continue blowing fuses, and we want to figure that out first before we try applying power again, as we don't want to burn out on yet another transformer, the little ground power TR. Alright, so what we're going to do next is to verify our pathways. So what we plan on doing is putting that circuit breaker panel back in, but leave the back open so I can keep a meter lead attached on the back side of this breaker, and with it connected and plugged back in, do some dead checks, or continuity if you will, to make sure that the power's leaving from here, and we have it on pin F down at the ground power plug. Now my meter leads are only a couple feet long, so what this means is that with the circuit breaker panel up there, one lead's attached up there, the other lead's got to make its way all the way down here. And then we're going to meter it right here at pin F to make sure it's that, oh I'm sorry, I'm going to meter it here at pin F to make sure that that pathway is good. If that pathway is not good, then that means that the main transformer rectifiers are not providing power to this pathway to keep the ground power contactor closed, which means that this gets overloaded and pops its fuse again. Alright, so here we are. Nothing is powered on the aircraft at the moment. All we're doing is checking the signal path. So we're on the back of the warning light controller breaker, which, how this is supposed to go is, it's just like we did earlier, checking from here to the back to the plug. Right now we're checking from here all the way down to pin F on the ground power plug. So we have this end here, we got a decent length of wire here to go, and we got another guy down at the bottom about to connect it. And if it's good, we should see a change on the meter because we're back on the diode checker function. All right, you ready down there?
Yeah.
All right, connect it please. Pin F. That's a good reading. All right, so this pathway should work for us. Excellent. All right, so that's one question mark out of our minds, because this is supposed to take over for that little ground power TR. So awesome. All right, we're good. Thank you. All right, that's all we got for the hangar this week. We kind of ran out of time, and it's lunchtime. We're all hungry, so we're gonna head out to lunch. But thanks for watching, y'all. We'll catch you next time.